Hi everyone, this is Dr. Rajesh Khanna, Associate Professor from Department of EEE in Hindustan College of Engineering Technology, Coimbatore. In this session, my presentation is about the basics of microprocessors and microcontrollers. What is microprocessor? A microprocessor is a computer processor which incorporates the functions of computer's central processing unit, that is CPU, on a single integrated circuit, that is ICs, or at most of a few integrated circuits. So the microprocessor is a multi-purpose clock driven register based and a digital integrated circuit, so that can accept binary data as input and processes it according to the instruction stored in the memory, and it provides a result as the output. So the microprocessor contains both combinational logic and sequential digital logic. So next we move on to microprocessor architecture, in which we are going to discuss about the first microprocessor, which is 8085. So the microprocessor is a single IC package in which several useful functions are integrated and fabricated on a single silicon semiconductor chip. So its architecture consists of a central processing unit, a memory modules, a system bus, and an input-output unit. So the system bus connects the various units to facilitate the exchange of informations. It further consists of data, address, and a control buses, which will perform a data exchanging property. So 8085 microprocessor is an 8-bit device. The central processing unit, which consists of one or more arithmetic logic units, that is ALU, registers, and a control unit. So based on the registers also, the generations of the microprocessor can be classified. A microprocessor consists of a general purpose register and a special type of registers for execution of instruction to store the address or data while running the program. The configuration of 8085 includes an address bus of 16 bits, a data bus of 8 bits, and a stack pointer of 16 bits, the program counter, which is shortly called as PC, of 16 bits, and a registers of 8-bit each. So this diagram shows about the 8085 microprocessor architecture. So here are some of the components which are present in this, particularly an accumulator, a temporary register, and a flip-flop, that is flag registers, and this one is ALU, arithmetic logic unit, and instruction registers, an interrupt controller, and serial input output controller. And these are the registers which consists of a register type, that is W, Z, B, C, D, E, H, L. Apart from that, we have a stack pointer and a program counters and increment decrement latch. Here we have an address buffer and also some of the timing and control registers are to be placed here. So the device works at 3.2 megahertz. So the architecture mainly consists of arithmetic logic unit, timing unit, and a control unit, instruction register, decoder, interrupt control register, and serial input output control. So that ALU, arithmetic logic unit, which performs the various arithmetic and logical operations, while the timing and control unit brings about the coordination between all the parts of the microprocessor. So another important basic microprocessor, which is 8086, which is an enhanced version of your 8085 microprocessor. So that was designed by Intel in 1976. So it is a 16-bit microprocessor which has 20 address lines and 16 data lines. So this particular 16 data lines that will be providing up to, that is the storage will be up to 1 MB. So it consists of a powerful instruction set which provides operation like multiplication and division. So it was the first 16-bit microprocessor, and which having a 16-bit ALU and 16-bit register internal data bus and 16-bit external data bus, which performs the resulting in fast processing. Okay. So we have three versions based on the frequency of the operation, that is 8086 and 8086-1 and 8086-2, in which the first 8086 has the frequency operation at 5 MHz and 8086-1 has the frequency version of 10 MHz and 8086-2 has a frequency version of 8 MHz. So another important thing is regarding this particular microprocessor is it uses two stages of pipelining, that is fetch stage and execute stage. So this will improve the performance. So this is the block diagram of 8086 microprocessor. So mainly it consists of two units. One is execution unit and another one is bus interface unit, which is shortly noted here as EU and BIU. So this particular EU, execution unit, which gives instruction to BIU stating from where to fetch the data and then decode and execute those instructions. So its function is to control operation on data using the instruction decoder ALU, and this EU has no direct connection with system buses. So it consists of flag registers that having two variations. One is a conditional flag and second one is control flag. Regarding the conditional flag, we have 6 flags. One is carry flag, auxiliary carry, a parity flag, zero flag, sign flag and overflow flag. Regarding the control flag, we have 3 flags. One is trap, the second one is interrupt, and third one is direction. So regarding the general purpose register, as shown here, this is AX, BX, CX and DX. So this AX, which is also known as an accumulator register, which is used to store operands for arithmetic operations. Regarding this BX, it is used as a base register. It is used to store starting base address of the memory area within the data segment. So this CX, which is referred as a counter, it is used in loop instruction to store the loop counter. And this particular DX register, which is used to hold input output address and for input output instruction. So regarding here, stack point, that is stack point registers, which is also a 16-bit register, so which will be holding the addresses from the start of the segment to the memory location, so where a word was most recently stored on the stack. So next we discuss about this particular BIU, which is a bus interface unit, which will take care of all the data and address transfers on the buses for the execution unit, like sending addresses, fetching instructions from the memory, reading data from the ports and the memory, as well as writing data to the ports and memory. So it has some functional parts such as instruction queue, segment registers and instruction pointer. So advantages of your microprocessor: so it can be programmed to perform a number of operations, and it is extremely fast, and it is capable of processing over 3 million instructions per second. It can be used to quickly move data between various memory locations. So regarding the application of the microprocessor are to be used in our personal computers. It can be used in laser printers, even in television and our day-to-day usage, that mobile phone, and it is used in various military applications and also in game machines and calculators. Hope you understand about the basics of microprocessor, which is 8085 and 8086. Thank you all. Have a great day.